let's get right to it. If you don't already have a techno crush on Shannon and Darren and the people over at Hak5, this little matchbook-sized squirrel will definitely change your mind. They packed a lot of nuts into this little guide, but there's one thing missing: power over Ethernet. So I heard that there was not enough room for power over Ethernet to go into this, but I don't buy that. So we're gonna crack it open and do that. The easiest way to open this case is with a box knife or a really thin screwdriver. I recommend the box knife because you're not going to have little screwdriver marks in the side of the case. So there are 3 tabs in this, 2 on each side of the button and 1 over by the flash drive USB port. This corner does have a small tab, but it's not the same as the other 3 and it doesn't hold as well. So we're going to start there and pop it open. Just get your knife right in the seam and turn it, and the case will pop open. And then slightly turn the case and do each corner. And once you've got all the corners started, you can remove the case the rest of the way. The extender for the selector button will pop out, as well as the payload switch extension. Those both pop out. Just pay attention to how they go in, it's not that hard. Then the board itself can pop out of the bottom of the case. I think it's easiest if you grab the 2 RJ45 ports, and as you're holding down on the case, pull up and pivot away from the case, and the whole thing pops out. So let's figure out where we're going to put the power supply that's going to change our 48 volts power over Ethernet to 5 volts, which this little guy wants. There is a lot of room in between the 2 boards, so I might look at maybe getting something in between there. I've looked at the clearances on the case, and there's not a whole lot of room. There is a little bit because of the solder, or because of the tabs and leads sticking up from switches and RJ45 ports and things like that. So there's a little bit of room right in this area, but doesn't look quite thick enough for our board, which has a pretty thick inductor on it. And the board I'm talking about is a DC to DC converter to convert the voltage down to 5 volts. Anyway, let's get into it. Okay, I know that from the current analysis on startup, the Packet Squirrel draws about 230 milliamps peak, and then it levels out after about 35 seconds to around 150 milliamps. So to test our DC to DC buck converter, down converter board, I'm going to make a dummy load just so I don't accidentally blow up the Packet Squirrel, because I don't want to hurt the squirrel. So we know going in we've got 5 volts. We know at a maximum it draws about 230 milliamps, so I'm going to round up and draw 250 milliamps, or 0.25 amps. And we know Ohm's law says that to make a dummy load, to find the resistance, Ohm's law, R equals E over I. So 5 volts over 0.25 amps equals 20 ohms. So I need a 20 ohm resistor to simulate a 0.25 amp load on our 5 volt buck converter board. So I'm going to use 2 10 ohm resistors and wire them in series because I don't have a high power 20 ohm. Okay, there we go. Quick and dirty 1/4 amp dummy load for 5-volt source. So let's hook this up and start talking about the 5-volt down converter. Since this micro USB B connector is solder or surface mount, there are no places to solder on the bottom of the board, and I can't quite get in there to solder anything, so we're gonna have to find somewhere else to inject the 5 volts. I know I can get it off of this other USB, the larger USB port that is through hole, but I want to make sure that the 5 volts coming into this is the exact same line straight through as this one, just to make sure it's not going through any filtering or whatever. Maybe or even a diode protection. Probably not, but I just want to make sure. So I know that the grounds are the same and 5 volts should be right here. So if I touch this to the 5 volt input on this, it is. It is the same, and I'm reading less than 1/4 ohm, so I'm going to call that good, and that's where we're going to inject our 5 volts. So the down converter board that I had laying around that I'm going to try to use today is from eBoot on Amazon. It's a MP1584 MPS based little board. It's made for 28 volts in and anywhere from like 0 to 12ish volts out is what the site rates it as, but we're going to be wanting to put 48 volts into this, so that's kind of double the input rating, but it's also rated at 3 amps, and I'm going to try using a little bit of trickery to get this to work at 48 volts. So that's what we're going to test. I'm going to hook up the dummy load to the output, and I've already got the output hooked up to digital multimeter, and I've got the input hooked up to a power supply. Right now it's running at 28 volts. So we've got 28 volts coming in. I'm sorry, 24 volts. 24 volts coming in, and I've got the potentiometer set to 5 volts output. Actually, right now it's at about, exactly 5 volts out. The little trim pot below the inductor is already set. I don't know if you can see that or not. So right now we're running, pulling a 1/4 amp, outputting 5 volts, 24 volts in, everything's working great. That's what it's rated, but I need to make this work at 48 volts input, because that's what Power over Ethernet supplies, is 48 volts. So rather than just plug this directly into 48 volts to start with, I'm going to limit the current going in with a 100 ohm resistor, and I'm just going to try that. I've got a bunch of these boards, so if I blow it up, I don't really care. Okay, so now we've got 48 volts coming out of the power supply. Have to drop across the resistor, and whatever current drop is being pulled by the board Looks like there's about 44 volts at the input. The output now is 5.5, and that's a little bit high, so it looks like I need to adjust the potentiometer just a little bit for 48 volts. So I'm going to do that. I'm just getting this 48 volt input to stay still. There we go. So I'm going to drop the output voltage down. And I know you can't see the other meters, but right now it's sitting at 5.5 volts output. And I'm dropping that down to about 5.1 volts. All right, so we're still holding, outputting 5 volts, 48 volts in, and the board is drawing 1/4 of an amp on the output. Nothing is warm. The MP1584 step-down converter chip, like I said, it's rated for up to 3 amps, and we're only drawing 1/4 of an amp. So it's not warm. The inductors maybe just barely getting up to warm enough to be able to feel it, but it doesn't really look like anything is being adversely affected. First glance, I'd say this is gonna work, but I don't want that 100 ohm resistor in there. So I'm going to go ahead and take that out and see how this thing handles the full 48 volts in without that current limiting resistor, which, by the way, is also maybe just barely warm enough to feel. I don't know, I think that's just room temperature. It's definitely not getting hot. So here is 48 volts in, and looks like now the input voltage on the MP1584 is sitting right at 48 volts. Still drawing 1/4 of an amp at 5 volts output. Probably shouldn't be using my finger to measure temperature, but it works. I'm going to go ahead and lower this down to be drawing 1/2 an amp, just to put this in a 50% over current rated situation. To do that, I'm just going to change from using 20 ohm load to a 10 ohm load. Interestingly, when we change from 10 or 1/4 amp load to 1/2 amp load, the output voltage raises to 5.3 volts. I'm gonna see what the temperature of the actual chip is. Looks like the 1584 is running at about my thermometer is broken. Never mind. Yeah. I'll deal with that later. Anyway, still running at 5 volts, 48 volts input, 1/2 an amp being pulled at the 5 volt output, and the inductor is barely warm, The 1584 is it's just now warm to the touch. Diode is about just as warm. That's the input. So I don't know. I'm happy enough with this. I'm going to switch back to 1/2 amp or 1/4 amp. The resistor's obviously running pretty warm because it's pulling 1/2 amp, but okay, well, let's go ahead and hook this up to a USB cable and power up the Squirrel using 48 volts down converted to 5 volts. No, no. Get rid of our dummy load. I'm going to go ahead and power it down while I'm hooking this up, just so I don't hurt anything. By the way, I'm sure this probably voids the warranty, so do it at your own risk, blah, blah, blah. All right, on a USB-A plug, pin 1 is on the left, pin 4 is on the right, I think. No, I'm sorry, I said that backwards. Pin 1's on the right, which is your positive VCC. Pin 4 is on the left, which is ground. Can't just clamp in the alligator clips on this because the metal case is going to short it out, so do this. I don't know if the data pins are hooked up on this or not, but you want to be careful and stay away from them. Just in case they are, I don't want to send power over those. It looks like I'm on the pins correctly without touching, shorting out to ground, but we'll see. It's a little hard to make contact on these. I think I'm just going to go ahead and solder power onto the board, since that's where we're going to have to be anyway. I got this working earlier with just regular 5 volts in to make sure I could do it on this, but it was a little tricky getting the wires lined up like this. I don't have a female version of this, so we'll just put some power wires on the Packet Squirrel. So I've marked the negative lead on this through-hole USB connector just to make sure I don't get mixed up with all the board flipping and twisting and turning. And I'm going to solder on some small 28 gauge Teflon wire. You can use pretty much any small wire in here, but I like the Teflon because it's a very tough, heat-proof coating that doesn't get scratched easily. And don't have to worry about it shorting out. Gonna tin the wires first. Re-wet these leads and solder them on. Okay, now we have our 5 volt input to the board, so let's go ahead and test that. Turn our 48 volts back on. So we've got 48 volts going into the down converter and about 5 volts coming out. It's actually a little bit below 5 volts because we've removed the load, but once we add this back in, it should go back up to 5 volts. Got my wires twisted. I need to make sure I'm hooking up ground to ground. Looks like this is ground. I'm going to mark it. Okay, hopefully it's powering up. Looks like we are drawing 1/4 of an amp and the voltage is almost back to 5 volts. I'm actually going to bring that up just a little bit more. Looks like we are booting up. Oops. This little potentiometer is kind of crappy. When you push down on it, it loses connection completely. And anyway, so we're running at 5 volts, pulling 1/4 amp, and we are booting up. So that looks good. 5 volts in, direct solder to the board. Now we need to get the 48 volts off of the RJ45 connectors to input into our down converter board. So to do that, we're going to look up the RJ45 pinout and find the pins that the 48 volts is present on, which is going to be pins 4 and 5 and 7 and 8. So on the RJ45 connectors, pins 4, 5 are positive and pins 7 and 8 are negative. Again, these are surface mount components, which is awesome. They can pack in more nuts into this little squirrel being surface mount, because through hole nuts take up a lot more room. But it makes it really hard to get to. I can see the pins down in there, but I don't really want to jam a soldering iron inside there. And unfortunately, this little motherboard, the riser board on here, it's soldered on as well. We could unsolder the header right there, but it's a pretty small pitch header, and I just really don't want to do that. I want to modify this as little as possible and even make it to where we can unmodify it if we want to remove the POE feature. So I'm going to use the multimeter again and see if I can find those pins up here on this transformer. I hope/think they are there, but if not, we'll keep looking and see if we can find somewhere to get to these pins, maybe even inside the case in the back, routing the wires through this crack, possibly. So we'll figure that out. So if we're looking at also, we want to make sure that we're using the right Ethernet jack. So holding it up with the light in the middle and the Ethernet jacks on the right and left. Ethernet in is on the left and out is on the right. And according to Packet Squirrel manual or whatever, the left Ethernet in goes to the target PC and right Ethernet out goes to the LAN. So in and out, that's kind of confusing to look at it like that. I like how the website is labeled better, where it labels target and LAN. So we know that we need to get our POE from the right jack. I'm just going to write that on there. LAN. So LAN is on the right. So there are two of these transformer chips. One is in the inside, really hard to get to, and the other one's on the top. Please be the one on the top connected to the LAN. Let's find out. No such luck. Awesome. Okay. Let's see, what are our options here? So when you're looking at the jack, if the tab is on the top and the pins are on the bottom, pin 1 is on the right and pin 8 is on the left. And the ones we want are pin 4, 5, 7, and 8. So I'm just gonna sit on pin 7 and 8 here and kind of start just looking around. I would think that pin 7 and 8 would get passed through, so that if there is POE powering a device, that the Packet Squirrel would pass that POE through to the device. You check that by seeing if the POE pins are connected. And it does not appear that they are. Four and 5. Now, the POE pins are not connected, so this little squirrel will not pass POE, it looks like. Unless it's going through something that the continuity meter is just not pushing through, like a diode, maybe. Let me reverse this to make sure. No, nothing. Just lower the threshold on this way down, just to make sure there's no resistance. So I'm going to lower the threshold on the continuity meter down to 1 ohm. So it should kick on pretty easily. Pin 7 and 8. Let's 7 and 8, nothing. So it doesn't look like this is going to pass POE. Just kind of disappointing. And to be honest, that almost breaks wanting this to work on POE, because if you're plugging into a POE device, or you're plugging in between a POE device and hoping to get POE to power this, you are going to be able to get that, but at the same time you're going to sever the connection to whatever that POE device was being powered, which that's not going to work. That sucks. So now I almost feel like I need to fix that at the same time we are tapping power off of this to power the device. So yeah, after a little bit more digging and verification, they are not connecting the POE pins, which are pins 7 and 8 and 4 and 5. They're not connecting those together, so this will not pass POE power, and those pins are also not going to anything. The only things going to the network transformers here are the data pins, so pins 1 and 2 and 3 and 6. Also the LAN side, which is where our power would be coming from, the transformer for that is on the bottom, underneath there, hard to get to. So I'm gonna have to do a little bit more to this than I wanted to, but I still want to make this work. First I want to bridge those power over Ethernet pins so that this will pass POE, and then also we want to tap off of that and power our DC to DC buck converter boards so that we can power this device off POE. So we want to pass POE and we want to power the board off of POE. So to do that, I'm going to have to unsolder the motherboard. It shouldn't be too hard. It's just looks like a little piece of sticky tape holding the board down to the payload selector switch. You can pop that. Oh no, that's not sticky tape. It's just foam to keep it from rubbing on surface mount components. It looks like little, yep, keep the board, I don't know if you can see that. So what we do have to do is unsolder the header from the board here and lift this off. Once that's off, we'll be able to get to the surface mount pins on the RJ45 jacks, bridge those together and pull our 48 volts off really easily. So let's get going. I think to do this, since this is such a small pitch, like a 0.5 or something pitch dual header, I'm not going to desolder those with the desoldering iron. I'm just going to use a solder blob to melt the solder and pull the board off a little bit at a time. Could use a hot air reflow, but I'd rather just wet that with solder and pop them out, and then we'll use the solder sucker to pull the excess off. Find a good spot to clamp onto this guy. Actually, yeah. I should hold it. And go ahead and saturate these pins with solder. Luckily, the pins are pretty long by the time they get to the top of the header, and there's a lot of area for the heat to dissipate, and there's not a lot of real sensitive components right around here, so I'm not too worried about hurting anything on the board. All the sensitive stuff is actually on that riser board, so well away from this heat we're going to be making. I just want to fill in the gaps with solder so that the heat transfers well once we start pulling this off, so it transfers to all the pins evenly. That should be enough. So I'm just going to put some downward pressure, pushing away from the bottom board against the riser board, and hope that it just pops out. Starting to pull away, but I'm going to use something to actually pry in there a little bit better. Plastic screwdriver. Screw it. There's some clearance. I can use a metal screwdriver and push against the USB case. Shouldn't hurt anything. Feel it pulling away pretty cleanly. I think I'm going to put this in a better vise. Finally. Looks good. Doesn't look like pulled up any pads or traces. So as long as it can withstand that heat, which it wasn't too much, it should be okay. Just clean up these traces. Okay, now we just need to bridge our POE pins together, as well as pull off positive and negative to input into our board. So we're going to bridge together pins 7 and 8 and 4 and 5 and join those together. So just got a longer lead and a shorter lead. The short one is for jumpering the two together. The long one is going to feed to our board. So let's go ahead and make the other jumper. Now I need to connect pin 7 and 8 together. So on this side, pin 7 and 8 is going to be all the way up here. Go ahead and bridge those together carefully. Should probably use a smaller soldering tip for this one. I don't use this small tip very often. I gotta get the scale off of it. And I need to tin it as well. Those are really easy to bridge together, so I'm gonna make sure and be careful not bridge the wrong ones. I'm glad I used a smaller tip on that. I'm gonna go ahead and bridge together 4 and 5 as well. Do that on all 4 of them, and then we'll jumper them together. Put our motherboard, riser board back on. 7 and 8. 4 and 5. Cool. Alright, those are bridged. Tin the other side of the jumper. or down gently. And do the other pair. We're going to jumper 4 and 5 on the land side. On the land side, over to 4 and 5 on the target side. Down flat because we're going to put a bead of hot glue on them just to make sure they hold in place and don't come loose or short out. But before we do that, we need to test this to make sure the pins are connected correctly. So I'm just going to go through and continuity check positive, negative to pins on both RJ45 jacks to make sure everything is what I think it is and what it should be. So pair 7 and 8 should be our negative. This is 7 and 8. And pair 7 and 8. Making on the land side. And on the target side. And nothing else is connected, so it's not shorted out to anything else. Just pin 7 and 8. And let's check positive 48 volts, which is pin 4 and 5. Are good. Nothing else but 4 and 5 on the land side. And let's check 4 and 5 on the target side. That looks good, no shorts, so we're on the right pins, and pins are connected through, so that should be good. We just need to glue this down and solder our riser board back on. And hot glue gun, so just melt it with a lighter and put a dab over the wires and then touching the top of the transformer so that those are held down securely. I'm gonna go ahead and clean up these pins just a little bit. I've got the desoldering iron warmed up, but this pitch is so small. I think I can do a better job just with some copper braid. Looks pretty good. Everyone is cleaned off and straight. All right. Looks like there's a manufacturer date right there. 5/18/2017. Brand new little squirrel. So I'm just going to do the opposite that we did when we were taking this off. Lay down another bead of solder that kind of covers all the holes, maybe. And then just push it through from the other side. Okay, I think I'm going to try to clean those holes out. Okay. Nice cleaned out holes. The board is popped back on. I'm just going to solder it back. Just going to clean off those connectors and make sure everything looks good. Just a mixture of alcohol and acetone. Looks like our board booted back up, so we didn't destroy it. All right, so now I need to make a Ethernet cable to insert 48 volts over the LAN RJ45 connector, and we'll use that to power our DC to DC converter board, and in turn power this, just to test and see if this is going to work with actual POE. Alright, so we're just going to make an RJ45 connector with one side of the cable or RJ45 jumper cable with one side of it just open for testing so we can hook it up to our power source to simulate POE. Okay. So we've got an RJ45 connector and one side open. We need to access the four and five and 7 and 8. So we just need to access the power pairs, which is 4 and 5. 4 and 5 is blue and white, and 7 and 8 is the brown. These are our data pairs. We're not going to be doing anything with those. So I'm just going to strip these two. Before I connect these together, I'm going to plug this in. Doesn't matter which side since we've jumpered it, and check continuity to make sure that our two pairs are joined together like they should be, or shorted together. So four and 5 are shorted together, as well as 7 and 8. So that's what we want. Twist those together. Alright, so we're going to put our 48 volts onto those pairs. So 4 and 5, which is blue and blue-white, is our positive. And negative 48 is our brown and brown-white. And 7 and 8. Make sure I wired the connector right. So 7 and 8 are negative, and 4 and 5 are positive. All right, 48 volts. I've got an old wireless router access point that's POE. I'm going to use that to test this. Looks like it's powered up. So, all right, so we're simulating POE. I know that works. It's powering this access point. So I'm going to move on to powering this with POE. So what we need to do first is now connect our board to the power in and power output. Power in is the shorter leads here coming from the RJ45 connectors. The 48 volts out, and our 5 volt input is here going into the USB jack. So I'm going to leave the leads the length that they are, because I'm not exactly sure yet where I'm going to be able to put this. As I said, I've played around with different spots in the case, and there wasn't anywhere that really fit great. It's really close. I could probably grind down a spot where that inductor is sticking up and get it to fit in a couple different spots, but I don't really want to modify the case. I could 3D print a different case with just a little bit more room for that board and inductor. But I think for now I'm just going to wire it and stick it on the outside of the Packet Squirrel. So it'll work, and then maybe I'll come back later and draw a case for it and print it out and redo it like that. So let's get these soldered up. I did mark these positive and negative on the output. So real quick, I'm going to insert 48 volts on this. Hope it doesn't blow up. There's no current draw on the power supply, which is good because it shouldn't be. And we'll see which one of these is positive. And mark the negative lead. Alright, now we can hook it up. So our negative input goes here, and positive in here. And then our negative and positive output. So there's our board wired up. Let's go ahead and test it, see if it works before we go any further. Drawing 1/4 of an amp. I hear a funny whining that I don't like. I'm gonna put some voltmeters on it just to make sure what I think is happening and all that. Stick the fluke here. I'm going to look at the input real quick. Should see plus 48 volts. Okay, that's good. Check the output. Should have our 5 volts. Perfect. 5.1, 5.2. It's close enough. I think what we're hearing is just some inductor capacitor whining in this buck converter. I didn't hear it before testing. Not really sure why I'm hearing it now, but let's go ahead and see if it boots up. Yep, there we are. Packet Squirrel getting all of its nuts directly from POE, and we should be passing POE as well. Let's check that real quick. I've got a little jumper here. while the Packet Squirrel is running, we should be able to power this access point. Nope. I tripped my power supply overcurrent. I don't know what this this guy draws, but obviously it draws more than what I had it set to, so I'm gonna raise that to an amp. See if that works. Our Packet Squirrel rebooted. Let's go ahead and plug this guy back in. That looks good. And it draws a little bit more than what I had it set to, and it did power up. So total, looks like this circuit's drawing about a quarter of an amp at 48 volts. So here we go. Packet Squirrel, POE powered, and passing its POE power through to POE device. So let's go ahead and clean this up and put the case back together and mount this somehow. Figure that out. By the way, at 48 volts, this is drawing on the 48 volt side, not on the 5 volt side. This is drawing about 20 milliamps. So well below any POE standard. And if there's any kind of power monitoring, it's, I think, a small enough draw that when you insert this between your POE device, if there's any kind of power monitoring alerting, I don't think it's going to be enough to trigger that. It's 20 milliamps is not a lot. So at 20 milliamps, that's only about 10 watts, 9 watts at 48 volts. Check for heat. No heat. Everything is cool to the touch. So we're really overdriving the voltage input on this nice little DC to DC buck converter, but we're drawing very little power, so I think it's going to be fine. I think looking at the gaps around the hole, the available holes on this, the USB port looked like the best option for routing these cables out. So that's what I'm going to use, and it kind of makes sense since that's the power port anyway. Just going to carefully route these out the USB port hole. Yeah, want to watch out for the edges of the USB connector. They're metal, and they you don't want those to dig into the power, because that would short out your POE or short out the 5 volts. Looks like it's okay. Let's get it all together and take a look at it, how how well that's going to work. Oh yeah, that looks great. Plenty of room there. As long as you're not pulling and bending on the wires a lot, there's going to be plenty of room for those cables. They're not going to be as pinched as I was thinking they would be. So let's put the button back together. There are two little tabs that fit into little square slots here, and then that button extender sits right in front of the actual button. And then the payload selector switch, there's a top and a bottom on this thing. You can see there's a tab on the top and there's not one on the bottom in the middle, so it slides over the switch and it straddles the case with two pieces of plastic to hold it in a straight line. Just make sure that's on and operational. And then we can put the case back on, make sure the LED light pipe is over the LED and the switch buttons are on the right side, switch button holes, and just snap it together. Okay, let's do another quick power test to make sure everything's still working. I saw the lights flash there for a second. Let's wait just a minute to make sure it boots up. Yep, booted up, powered over POE. Now we're just gonna glue this little guy down. Actually, I think I'm gonna put it in some heat shrink and then glue that down. The output cables were a little bit longer than the input cables. That actually ended up working out to allow those to fold down, and since they're traveling about 1/4 of an inch longer, it ends up with the rest of the cables lining up pretty well. Like to get the ends a little extra warm, and then you can use a pair of needle nose or something and crimp it down to seal it. Cut off the extra, nice sealed little bubble package. I'm also gonna glue this down and cover up the Packet Squirrel name because nobody needs to know what this is. It's just a magic network thing. Alright, got the wires routed. And two, this will still operate on 5 volts using the USB port. And just to prove that, let's do that real quick. There we are, booted up, running off USB. Doesn't affect the module. It's got diode protection. Let's check POE again just to make sure. We'll check both sides. Alright, target side works. We can power it from the target side, which we wouldn't be doing. And here's the LAN side. Good to go. Double check to make sure we're passing POE again. Looks like we are. Little awesome. So there we go. Get the module glued down. Yeah, I have a hot glue gun, but it's way over there. Plus it takes like 30 seconds for it to warm up. This takes 10 seconds. Awesome. There we go. Packet Squirrel, power over Ethernet, pass through, and power over Ethernet powered. Cool. Thanks, guys.